So I'll cover two sessions today. First one we'll cover is our analytic database, as Fred alluded to earlier. That will be a little bit more slide and content heavy. And the second session will be our data science, and as that is a new product that actually just got launched today, or actually yesterday, sorry. We'll do a live demo of that. Fingers crossed that everything works well, as I'm actually in a pre-release of that build. So first, I want to cover our analytic database and our efforts to enable organizations to modernize how they think around BI and SQL-based analytics. Specifically, I wanted to cover three sets of questions that we get a lot. What are the benefits? What benefits can organizations achieve from modernizing, and what do we mean by modernizing? If I decide that I do want to take advantage of modernizing, when and how do I determine what applications or what use cases to migrate off of traditional systems, and what does that process look like, and what assistance can Cloudera offer in that? And then going a little bit deeper on what Fred had set up specifically around the analytic database. How does the analytic database look in the cloud? Different types of design patterns that Fred sort of briefly touched upon, and what additional benefits in terms of modernization and self-service does the cloud offer within the analytic database use cases. So first, when we look at the analytic database, there are three key application patterns that are the dominant patterns for use of our analytic database. First, data preparation, fast SQL-based ETL and data engineering. Second, self-service BI and exploration, the ability to be able to allow users to be able to navigate new data sets, ask new questions of existing data sets, and find new insights. And third, the ability to optimize their data warehouse, looking at application patterns that we're running in traditional data warehouses and seeing which ones of those might be good suited to move on to the Cloudera platform to let the data warehouse focus on the applications that it does best and drive a more cost-effective data warehousing environment by using the combination of Cloudera and the data warehouse. Going a little bit from the bottoms up, when we say Cloudera's analytic database, what exactly do we mean and what comprises our analytic database? So as Fred talked around, at Cloudera we have 4 different application patterns, analytic database being one of the 4, along with data engineering, data science, and operational database. All of these products are built on a common platform underneath. Our vision here is that you have one platform, one set of data, one set of governance that you can use across these different types of product patterns. So our analytic database, the key components on top of the core unified platform and our Cloudera Essentials are these 7 components. So Navigator Optimizer, I'll actually touch upon this a little bit more in depth later. This is a tool to help you identify what workloads are best suited to run in Cloudera, which ones might be more challenging to run in a Cloudera environment from your traditional data warehouse and database environments, as well as help you continually optimize your analytic database in Cloudera. Navigator, I imagine a large portion of this room is very familiar with Navigator. This is our governance tool enabling you to provide auditing, lineage, management, and building life cycles off of that. Q stands for Hadoop User Experience, and starting with Cloudera's release in 5.7 last year and beyond, our primary focus for Hue is on the SQL editor experience. You'll see why in my next talk when I talk around the experience we're building out for our data science environments and how those start looking very different, and really aiming on providing the optimal editor for a SQL developer and user, and the optimal editor for a data scientist. For analytic database, the majority of our usage really comes from our BI partners and the tools that the SQL users know best. So we do quite a lot of work with leading BI partners to integrate better with them. And the core engines underneath, For your ETL, on SQL-based ETL, Hive is the key engine there, whether you're running on MapReduce or increasingly on Spark for incrementally faster processing. On the other side, when you're looking at humans interacting with the system either through a BI tool or directly through SQL applications, Impala is the interactive SQL engine there. And just recently, in January of this year, we launched Kudu to GA, which provides an engine that enables fast-changing data. So whether that be fast incoming data or that end up allowing you to merge operational database and analytic database to be able to run analytics directly on your operational systems as and when the operational system isn't making updates there. This analytic database runs across on-premise and cloud environments. So regardless of whether you're running some applications on-premise or whether you're running some things on cloud, you get the same functionality and capabilities in both environments with a bit of the twist that Fred had talked about, and I'll cover a little bit more in the later part of this presentation on the additional benefits that we can take advantage of in cloud when you have hardware and infrastructure on demand. When we look at the key benefits of what you get from our approach to analytic database compared to traditional systems, in addition to the high performance interactive BI and SQL that your users expect from interacting with traditional database systems, we give these next three additional benefits. The ability to provide greater flexibility to be able to bring in data sets, bring in new use cases more iteratively along the way, and I'll cover that difference in more depth. The ability to not only be more cost effective in running on today's scale, but also more cost effective and more capable of being able to add infrastructure on demand. So you can incrementally add nodes, whether you're looking in on-premise or you're looking in a cloud environment in a way that you historically would not be able to do with your traditional data warehousing environments. And of course, while SQL is and will continue to be the most common way that users interact with data in organizations today and in the future, we see more cases where people are looking to take advantage of more advanced analytics and machine learning in addition to SQL. And so the ability to have this common platform where you do not have a copy of your data for your SQL environments and then have to maintain separate copies for your data science environments. So the ability to be able to have this open architecture where you're running your analytic database on the same data as you're running the other three application patterns becomes key. So I'll go into a little bit of now well, what enables our analytic database to provide those additional three benefits in addition to the performance that you expect from traditional databases, and compare and contrast. So looking at a database, regardless of whether you're looking at traditional databases or our version of a database at a super high level within any database organization, within any database you have the query engine, which is responsible for taking the SQL and translating it into efficient execution plans, the storage engine, which is responsible for storing the data effectively and making it easy to retrieve for these execution plans, and then a catalog service that defines the schema of what the data looks like. In fact, most database companies at some point in their lifespan were organized in these ways. When I was at Microsoft working in SQL Server, we actually had two different product unit managers for the query engine and the storage engine as two different units. I know Oracle and Sybase went through similar kinds of organizational structures. In the traditional databases, though, these are all internal implementation details. You are never writing directly to Oracle or Teradata's storage manager underneath the database. You are loading it through Oracle or Teradata or Vertica or whoever else, and they take care of laying out the data and managing the data. So this is all internal componentry. In our approach, we have the same sets of components when you look at our SQL and our particularly our interactive SQL engines, but we've decoupled these. So for us, our storage engine is Kudu, S3, and HDFS. And of course, you can go directly and interface directly with Kudu, S3, and HDFS. You can load files into our system prior to defining what the structure of those files are, and then later define the structure and query against that. Our catalog service is a common Hive Metastore service. And when we're talking around interactive BI and SQL, our query engine is the Apache Impala query engine. This difference in providing a similar kind of componentry in a decoupled way is what enables those other three benefits. So when you look at traditional databases, you have that very coupled model where you have to define the data model prior to loading any data into that system. So you spend time thinking around what does the table structure look like, then I load the data, and then I query that. And if I want to make changes to that, it has implications to how the data is laid out. So this has implications all the way through that stack. Sizing, because of this tight coupling, you don't go to your Teradata system or your Netezza systems or whatever your database system might be and just incrementally add nodes along the way. Things like indexes and projections need to be rethought as you're adding in additional nodes. So even if you're running in the on-premise environment, you're not adding incremental nodes along the way without doing restructuring. In most database systems, Vertica does have some capabilities to be able to add nodes along the way. And this world is limited to SQL. So to the extent that you're looking at taking advantage of your organization's looking at providing advanced analytics, machine learning, data science, or looking at some forms of the ETL processing that is better expressed in procedurally rather than through SQL, you are constrained and have to have other systems be able to be provided for that. As Fred talked around earlier, when you're looking at cloud environments, the ability of Object Store to provide a global store that lives across multiple different tenants is a key part that enables the flexibility and agility that you get in cloud. When I have these things tightly coupled together, then taking advantage of Object Store is not something that comes easy to these systems. And so it's pretty poorly designed to take advantage of cloud to the extent that organizations are looking at that. By contrast, when I look at the decoupled architecture with the approach that we offer at Cloudera, you have more flexibility to be able to more iteratively define your data model as you're doing analysis. So you can actually store data, be it in HDFS or in S3 or in ADLS. You can store data into those systems and then after the fact define what the structure of that data looks like and refine that. So we have organizations that will start with loading a whole bunch of application logs that they may or may not use, then later saying, let me go and look at these application logs, treating them as single column tables, searching kind of regex expressions, basically using it as a massive grep engine to find what application logs might be interesting for a particular signal that they're looking for, whether it's a particular person, an organization, or other kind of signal, and then later refining that further, and doing so in raw text before defining when they go and store it in a more optimal structure. That enables you to be able to bring in more data sets more cost effectively, not just from a cost of storage, but from a people and process perspective as well. Our system is designed to be able to provide incremental scale. Obviously, cloud gives you that to the next level. We'll talk around that more in depth. But even on-premise, you can add nodes on an incremental basis and don't need to re-lay out and rethink how you lay out the AMP servers or how the indexes need to be recomputed and the like, that the system is designed from the get-go to be able to add nodes incrementally on-premise or on the cloud. And of course, everything here is built on the common Cloudera platform. So when I talk around the data science in the second talk today, that same set of capabilities is available on top of the same data set that you are running your analytic database on. So that open architecture and open formats means you can go beyond SQL, and that also extends to things beyond Cloudera as well, that you can, through these open formats, you can build applications that interact directly against these open formats and build your own kinds of applications that might not use Cloudera's frameworks to compute against them. And the ability of that decoupled storage made it so we had to do some work to be able to take advantage of S3 and more work for ADLS and Google Storage, but architecturally we were well set up as we started from the get-go of having a decoupled query engine from the storage manager with HDFS and Impala and Hive and the like. So we're quite well suited to take advantage of the cloud storage and elasticity. So now that we say that we have these sets of benefits, what does it look like to go from, and how do you determine what applications might be well suited to go and run on this modern analytic platform, and which ones to keep in your data warehouse environments? Our view in this is not that we are replacing your data warehouse and in the end you just have a Cloudera environment. Our view here is we can actually complement and allow you to use your data warehouse for the repeated set of reports that you're running regularly, while enabling your organization to be able to do more kinds of self-service exploratory analytics and other terms of analytics alongside of those environments. A lot of the motivations for why organizations look at optimizing their data warehouse and expanding that footprint with Cloudera alongside of that. One, data is growing at a rapid pace, so even if you aren't adding in additional use cases, you're finding these environments getting more and more constrained to handle just the growth of data. More organizations looking at doing more data-driven analysis means more users are using the sets of reports and sets of data within these environments. And so even if you aren't looking at expanding the footprint, keeping the cost structure that existed a year ago and with the same set of use cases today is proving more and more challenging to a lot of organizations. On top of that, we see continual need from the organization to be able to take on new workloads, new use cases, bring in new data sets. So you now have a system that left to its own is already butting into constraints, and you have more needs that are coming in. We see more and more users looking at trying to take advantage of more of these self-service BI and exploration in addition to sort of the CAN reports. And data warehouses historically have been designed very well to be able to handle these fixed SLAs, where the self-service BI, where you're taking advantage of some of these two new tools like Tableau and ClickView and Spotfire, end up being sort of the caged animals that you sort of try to contain from impacting the reports that are running your business on a regular basis. Top of that, we see self-service BI, advanced analytics, and the shadow IT and the need for a more flexible kind of infrastructure growing in needs within these organizations as more people look to be able to explore and leverage data in more and unique ways. And so the previous platform, it isn't just the case that, hey, most of my workload is these fixed set of reports and there's just a few of these sets of users that need more advanced kind of use cases. Those advanced kind of use cases are growing faster than the traditional reporting, and there's more and more needs from the IT organizations and the management organizations to find a way to be able to embrace this rather than look at this as the exception rather than the norm. If we simplify a lot of what we see in organizations today, you have a bunch of different data sources that go into staging environments, and typically it's actually multiple staging environments and multiple data sources coming in. Just simplified it here, funneling into data warehousing environments. And in order to be able to take advantage of these self-service BI and additional use cases, we see a lot of these organizations looking at shadow IT and data marts popping up, where the end users and organizations are finding that, hey, I need to find a way to be able to answer the questions that I'm looking at. And they might take portions of data from the data warehouse, additional data sets that they're looking for, and saying, it's easier for me to sort of manage my own sets of systems alongside my data warehouse than it is for me to try to find a way to be able to add these new use cases in through central IT. This leads to a proliferation, which in its simplest form looks something like this, and more likely ends up looking like data marts built on top of data marts, that from a security, governance, and IT control perspective becomes quite painful, and from the end user's perspective, the spider web of finding how do I manage what data sets belong where gets messier and messier over time. We see a lot of organizations start looking at Cloudera starting from a cost perspective and saying, well, Siemens, for example, looked at over 90% less cost per terabyte compared to their traditional data warehouse that they choose not to name, but one of the big players that you can probably guess. 75% less than where they were, the technology that they were using more in some of their data marts and staging environments. But for them, it was not just cost, that ability to go beyond reporting and be able to find that the data mart world can actually be simplified in a way and provide a platform that embraces the ability for people to add data sets and augment the core reporting, and taking advantage of self-service and saying this is part of what IT and what our organization delivers as a first-class citizen, rather than something that the consuming organizations need to go and take advantage of. So we see more and more organizations looking to an environment that looks like this, where they have their data sources coming into the Hadoop platform, all vendors in the industry seem to violently agree that Hadoop and Cloudera's technology is the right place to do data engineering and data preparation. In addition to that, we see most of our customers looking and saying, well, I can actually use Cloudera and the flexibility that has been built into the Cloudera platform that enables this more modern approach to an analytic database to enable a true home for self-service BI and dashboards and this more flexible analysis in addition to going beyond SQL. And so instead of having more proliferation of data marts looking and saying, let me actually let this exploration happen directly in that Cloudera environment, and continuing to use the data warehouse to run the key fixed reports that are running the business. So those curated reports that you're looking at, particular metrics week over week, month over month that you're running a lot of the organization on, still funneling that data into the data warehouse to go and serve those things up. But now having a home to take advantage of these self-service BI and explorative use cases, whether they be in SQL or non-SQL. So the challenge now to go from that previous world to this world and finding what reports and what patterns fit within our platform and what belong in the data warehouse and what order to go and move these ends up being a challenge for a lot of organizations. And that's where we have a tool and a process that we've been working on for a long while. So regardless of whether you take advantage of Navigator Optimizer or you work with our organization, you typically are going to look at a series of stages of how do you figure out what workloads are good fits to move onto the platform. You want to be able to look at trying to do a POC to prove out any of the questions that you might have around the validity of the platform. Then as you go in and saying, yes, I want to move forward with this, figuring out what the impact of moving a set of workloads onto our platform is, which ones to prioritize in what order, and actually doing the heavy lifting of determining what the schema looks like, what changes you might need to make as you go and offload this, and as you are taking advantage of a self-service platform, how you continually optimize this. So Navigator Optimizer is a cloud service that we provide that analyzes workloads, whether it comes from a traditional database platform. We now support most major traditional databases to get logs from an Oracle, a Teradata, a Vertica, a Netezza, and many more. It is not yet available in government cloud. I do want to touch upon it here as we look to your feedback to help us prioritize if and when we go and move this into government cloud. So please do work with your account teams if you do find the specific implementation that we have here interesting to you, and that would be a key impetus for us to make this available through government cloud. Regardless of whether you use Navigator Optimizer or whether you go it on your own, the same methodology and breakdown would apply in with or without Navigator Optimizer. Navigator Optimizer, as I'll show you in a few slides here, makes doing the bolded things that are quite challenging to do on your own much easier as it analyzes your workloads more holistically. So now, just wanted to touch briefly on terms of the kinds of benefits you get from Navigator Optimizer and breaking down this evaluation planning, offload, and continual optimization. So as I'm going through the evaluation phase, you want to be able to find what are your common patterns, what are top queries, looking at top application patterns, identifying which ones of these might be a good fit to do a POC, as your organization is going to want to be able to try and say, let me make sure that this is the right path to go down and prove it out on a small scale before I invest quite a lot in that. And so this helps you look at the overall workload in your system and see through the spaghetti mess and see different slices of what your workload looks like. In the planning phase, as I now look at the impact of moving these over, I want to be able to understand what actually constitutes a workload. I can't just move over individual reports or individual queries if I'm going to force a user and say, hey, when you do this, go to Cloudera. When you do that, go to your data warehouse. We can actually identify as a collection of what are all the things that this user or group ran, and then from that, be able to identify what are easy things to move over and what are hard things to move over. That you, as you look at this process, you want to be able to look at, say, let me start with some of the easiest things, start moving those over that give me the highest ROI, and work towards the more complex scenarios. And through Navigator Optimizer, we're able to identify collections of work that make up a unit that can be moved and do a complexity assessment. So you see like the top chart here shows a workload where most of the workload looks quite easy. There's a few areas of complexity, while the bottom one shows that larger red bar saying that actually most of this workload is going to be more involved for you to go move over, so you likely want to consider that at a later stage. As I go into the offload requirements, as I start looking and saying, well, some of that was more complicated, what exactly is more complicated and what is the work that is entailed? I can now drill into the specifics of this migration and see what changes or what optimizations might you need to go or might you consider doing in doing that set of migration, and gives you actionable recommendations in saying, based on your workload pattern, here's what we might recommend to be able to optimize that for the Cloudera platform compared to what you are running today in your Oracle or whatever other database platform you're running in. And lastly, especially as you look at an environment where your aim is to enable more self-service and more use cases to come on board, what your environment looks like today compared to a year from now is going to change by virtue of the fact you're adding and you're enabling the users of this platform to be able to change the workloads more continually. And so this can do that same process just looking at Cloudera's platform and give you recommendations and areas where you might optimize to what the workload is going to look like in 6 months from now. Again, this gives a little bit of a view into what the tool does. You can obviously do a lot of this without the tool. It's just some of these things get a lot more difficult if you think around how do I look at the collection of reports that make up one portion of your organization's reports. You may, depending on the visibility and how well you track that, you may or may not be able to do that well without this tool, but the tool is designed to be able to make that an easier process there. So now we talked a bit around the highlights of the benefits of why consider augmenting and expanding your data warehouse environment with a Cloudera environment alongside of that. We talked around how to get from point A to point B. I wanted to talk a little bit more in depth on what Fred touched upon in terms of cloud and how cloud, what benefits you additionally get by running in cloud, and a little bit more into the application patterns when Fred talked around that BI application patterns, and when you might choose the recommended pattern and some of the best practices there, and when you might choose some of the other patterns as well. First I'll skip through this quite quickly. When you're looking at what's driving to cloud, or executive mandate, agility, elasticity, and in some places cost effectiveness. I'll get rid of this build slide. One thing to consider, as Fred had talked through, when we do, and the market does surveys, we see most organizations already today are or will be in hybrid cloud. When you're looking at hybrid cloud, it's important to be able to look at the ability to have a common platform. You don't want to have, if you are looking at a hybrid cloud environment, your organization have your users know how to use one system if it's the on-premise system, a totally different system if it's in cloud, and then if you are looking at application patterns that might move from cloud to on-premise or vice versa, having to, in making those transitions, not only have to worry about moving the data in the application over, but also seeing whether you need to retrain your user audience. So portability, consistent functionality, and considering data gravity becomes important there as well. Fred sort of touched upon this already. 2 patterns in Analytic database to consider here: ETL, which looks very much like data engineering. I'll go lighter on that, and BI and SQL Analytics, and I'll cover a little bit more in depth on this pattern. When we look at the benefits of cloud, so in that second or third slide, I talked around the core benefits of our Analytic database being the ability of not providing the interactive and concurrent performance that you're used to with your traditional database systems, alongside greater flexibility to add data and use cases, the ability to provide more incremental scalability, and that open architecture. Building off of those same benefits, cloud enables some additional capabilities taking advantage of infrastructure on demand. So in addition to giving fast performance when you're running on your cloud system, if I now start having separate clusters for different tenants, you, instead of having to have all your tenants share a common platform and use resource controls within that, and managing a fixed cluster size for these tenants and figuring out how you prioritize within them, you now have an additional lever that each one of these groups can grow and shrink their needs without causing impact or without having to borrow from their peers next to them. So if I have separate tenants and separate clusters sharing common data underneath, I can give more predictable results that when one tenant group wants to increase their usage, they can actually just increase the number of nodes and grow their particular cluster without having to take away nodes from or take away resources from that might be available to another group. So giving more predictability in terms of response times because of the ability of having these multi-tenancy via isolated clusters on shared data. Building off that flexibility to be able to add data and use cases, the ability to have shared data that lives in an object store enables these clusters to share common data in a fully isolated fashion. So if I have my core reports running off of one cluster that is running against data in object store, and another tenant group wants to use that data and combine it with another set of data that is theirs, they can combine multiple S3 buckets together in a distinct cluster, sharing the same data that's being used by the reports without having to have those run in that same cluster. Again, giving them even greater isolation than if they were to do that in an on-premise environment. So making it even easier to be able to add data and use cases on an on-demand fashion from these organizations. ETL, you can have more contention for ETL. A lot of times in organizations today that they look at running their ETL jobs in off-cycle times to be able to make sure that when people are running their key reports or running their sets of analytics, that the hardware is readily available to them, and they start looking at how do I manage when ETL goes and runs. If I'm running against this common object store underneath, I can run ETL at any time that I want and not have it impact the jobs that are, the queries that are running, because these are running in isolated instances, and I can grow and shrink my hardware that's allocated to ETL completely independent of the hardware that's allocated to the individual users. And of course, I get just-in-time resources. So instead of having to project what will your usage look like in 6 months and a year from now, you can just adjust as and when you need that. Whether that's an adjustment that today something happened and now everybody is all of a sudden hammering the system and you need to increase the hardware today, or whether that is, I don't know if this use case is going to pick up and everybody's going to go and use that, or it's going to, I'm just going to sort of try and experiment and drop it off, that you can just get the resources as and when you need them. Because of these benefits, Fred sort of touched upon this, and I'll go a little bit more in depth on these. There's 3 different application patterns that we see. One is your transient BI kind of clusters. These are your clusters that you spin up as and when you need them. You have your persistent BI running against object storage, and then you have your persistent BI that uses local storage in addition to object storage underneath. Generally for BI, as Fred mentioned, running against a persistent BI cluster with object store is generally your best and default choice, as you typically do not, unlike data engineering where you sort of, the job is a controlled and scheduled entity, here you have users that may be running queries at any given time. So what we typically find organizations will do is have a cluster that runs a bunch of nodes during the day, and you kind of go to your skeleton crew at night, but you don't want to have 5 p.m. hit or 6 p.m. hit and say anybody who's trying to work late to get the report ready for the next day has to wait until 9 a.m. the next day. So you typically have your skeleton crews so that there is something available, you just right size it to the demand. This gives you the best when your workloads are more flexible and aren't sort of steady. Trade-off here is by running against object store, you are running a little bit slower on a per node basis, but typically the recommendation here in the way that Amazon and Azure and folks have networking is they give you a certain amount of bandwidth and latency to the object store that scales with the number of nodes. They've done a lot that in terms of their networking infrastructure to go and do that. And so you typically recommend here is thinner nodes and more of them to be able to make up for the per node the per node bandwidth difference between running against Object Store compared to running against local storage. The next pattern that we see here is where you start finding that your workload is more regular and consistent, where you have tighter SLAs, or you require faster changing data, where you need something like a kudu to be able to handle data updates that object storage is not designed to go and handle. That's where you look at augmenting the object store with local storage. And a key thing here is it need not be a choice of putting all your data into the local storage. The same cluster that has an HDFS component for local store data or a kudu component can still interface with the data in the object store and mix and match between them. I could have some data that I keep my most recent partitions in HDFS and historical partitions in S3 or any other kind of combination that I'd like. So this ends up giving you less elasticity than running against object storage, because if I'm now growing and shrinking nodes within this cluster, it has implications to the data that runs locally within that cluster having the ability to go and span out. This gives you less isolation, so the data that would exist in that local storage would not be something that would be available to other clusters. So some of the benefit we talked around having multiple tenants in their own clusters starts going away here. And if I start having more variant kind of workloads where off-peak I run less workload, I have less ability to be able to make that adjustment, because decreasing the number of nodes also means I'm decreasing the amount of local storage available to that system. So I have a floor in terms of how many nodes I can go down to if I go into this kind of environment. And this is the one that you see some organizations look at starting with this as they're moving things from on-premise to cloud, because this looks most similar to what they have on-premise. So it requires the least changes and least changes in terms of expectations from the platform, from performance and other kinds of capabilities. The third pattern around Transient BI, we see this less often. While this is the default choice when I'm looking at ETL, this ends up being a lot less frequent in BI cases here, mainly because this means that I now am scheduling my usage of that system. And so this works well if you are saying, hey, I have an exploratory use case that I'm going to spin up my own thing, try things out, and then I might want to sort of throw it away. It does require that the BI user or that organization be a little bit more adept in sort of spinning up and managing the clusters on demand. But you get some amount of latency. If I were to do this every time I was going to run a report, I say, hey, before I'm going to run a report, I'm going to spin up a cluster. I lose a couple minutes before I go and get that cluster up and running. That may not be the most cost-effective way to go and do that, especially if I'm going to run just a few different queries now, look at some of the results of this, and then analyze that. Having my own dedicated cluster to go and do that might be a bit overkill. So it is an available option in our platform, but we see this less often than the other two patterns for BI use cases. So I know I blasted through a bunch here, but hopefully this gave a little bit of a view in terms of what we mean by modernizing IT, the benefits of giving you performance on par with traditional database systems, adding in the flexibility to do more iterative data modeling, to be able to add in data sets and use cases more flexibly, to embracing self-service and exploration as a key part of what your organization needs rather than an exception to your data warehouse, the ability to be more cost-effective in scaling, and the ability to build on a platform that gives you an open architecture so that you can not only run your critical SQL on the same data, but running other things like data science and some of the data engineering capabilities that I'll cover in a bit. So I have just a couple minutes here to answer any questions that you may have around any of this.
My question is a little bit broader. So it's going to be more around automation. You talked a lot about on-premise deployments and how to migrate to the cloud and various strategies. So in terms of, let's say that I have a large on-premise cluster and I want to migrate to the cloud, does Cloudera provide any kind of tools, or are they thinking about anything in a roadmap in the future on how to make it easier for large on-premise clusters, existing clusters, how to consider it as a new deployment to the cloud, and also any future, how do I maintain continuous deployments to these, from on-premise, there could be some on-premise installations of Cloudera, there could be some, cloud-based installations, interoperability, and, how do you kind of manage it? Because this is like an 800-pound gorilla, right? I mean, it's a lot of stuff to manage.
Yeah.
So is Cloudera thinking about, any kind of automation around it, or is it up to the customers to actually do a lot of scripting and, maintenance, and spend a lot of time in actually, moving away from the on-premise, and what flexibility that we are losing from, by moving to the cloud?
Yeah.
Can you touch up on all this?
Sure. Yeah, great question. So I'll break that into 3 different things. One is the process of migrating and what we do to help automate there. The ongoing, what do we do to help you manage, what are we looking to do as well to help you manage your infrastructure, whether it be on-premise and cloud. And then third, which is, hey, you've been talking around benefits of cloud, are there any downsides or things that I should be aware of? So in terms of migration, today we offer, as part of Cloudera Manager, we have this BDR offering, which actually a large part of the migration is how do I manage moving the data over to that environment and keeping it up to date as I'm doing that migration, be it that I'm doing a DR site over there or I'm doing a permanent move. And so BDR helps moving not just data, but the metadata and other things that are associated with that into a cloud, cloud environments or between clouds or between on-premise environments. So that ends up being a very key piece of being able to go and do those migrations. We've done this quite a lot. We have many organizations that have gone through these migrations. So a lot of this isn't in the migration process, it's not a huge amount to go and help orchestrate. We're not touching the applications that you guys are running on top of that, but there is a bunch of best practices to go and look at in terms of what your hardware and SLAs look like on premise and what the right sizing looks like in cloud and what you can expect there. That really comes through a lot of our engagements with professional services who have gone and done this for a good while. So that's kind of a lot of what we have now. When I look into managing these ongoing environments, in cloud, actually some of the management of these environments gets a bit easier with some of what Fred was touching upon with Director that helps manage growing and shrinking and sort of manage infrastructure as a flexible component. Something that we are looking at as people embrace some of the cloud, they look and say, hey, I like some of these benefits of what you're giving me in cloud, but I also would love to have some of those capabilities in the private cloud. And as some of the networking infrastructure in particular is going through some bigger changes, we are looking at ways to be able to bring some of that same agility that you offer in public cloud into private cloud as part of our future roadmap, as well to give you common kinds of management and infrastructure there. Last piece that I mentioned is Director, whether it's running in cloud, can manage multiple clusters, as well as CM today. Even if you're running just on premise, can manage multiple clusters, so there's benefits that we can do there. We are making Navigator more multi-cluster aware to be able to manage these types of environments and look at governance when it spans across public cloud and private cloud. There's a longer conversation that at the end, close to the end of the talk here, so I won't be able to go into full depth here, but happy to talk more in a breakout session. Last piece, which is a great question that around, hey, are there any downsides that we should be aware of when we're going into cloud? So one thing I would very much look at is a lot of organizations look at, say, going to cloud and saying, hey, this is always just cheaper, and that's my motivation to go look at running in cloud. Important to actually do work with us to do some of the math on that. Where you do see a lot of savings in cloud, from a pure cost perspective, is where you get to save on not having hardware that is running if I were doing it on premise. Particularly if you're looking at more of these transient scheduled kind of workflows, where if I have a batch job that's running on a nightly basis that requires, let's say, 100 nodes to run every night, or let's say I'm running it every few hours, to go and pay for those additional 100 nodes of capacity and figure out how to time slice to take advantage of those when I'm not using that, that's where you get a lot of the cost savings. If I have a system that is running 24/7 on a pretty fixed set of hardware, at least today, even with some of the cost efficiencies that have come into from EC2 prices and Azure prices and Google prices dropping, you typically find that if you have a well-maintained data center, you can run a set of machines more cost effectively on-premise compared to cloud. So that's a surprise that is actually important to go and look through that. That's why you see Amazon has made an investment in their EMR often really only offers that transient kind of use case, but that's kind of where you can get the best set of cost savings from cloud, and they don't really, they do actually a pretty poor job in managing long-lived infrastructure, as that's something that you see less often running in cloud today. So that's kind of the main thing that I would say is when you're working through that, is don't take cost as an assumption that it is always cheaper, and particularly looking at long-lived, consistent infrastructure and comparing that cost against you running that locally.